Okay, now we can get to 10.7, which is partial fraction decomposition. Let's just explain what it is that we're trying to do. Let's recall this. So if we add fractions, we all know how to add fractions, like 2 over x plus 3 over x minus 1 minus 1 over x plus 1. So in order to do that, find the LCD. The LCD is x times x minus 1 x plus 1, which means we're going to times the first fraction by x minus 1 x plus 1. We're going to times the second fraction by x plus 1 to have the same denominator, and times this guy by x minus 1 x minus 1, and then we bring this down. So if we've x minus 1 x plus 1 is x squared minus 1. When we times it by 2, we get 2x squared minus 2. 3x times x plus 1 is 3x squared plus 3x. And then minus x times x minus 1 is minus x squared plus x all over the LCD. So now 2x squared, 5 minus 1 is 4x squared, plus 3x plus x is 4x, and then minus 2 over x minus 1 x plus 1. Now what we're going to learn today is how do we go backward. Decompose one fraction into partial fractions. Okay, there are steps for going backwards, okay? And the steps are listed under content. When you go to content on D2L, on the left side menu, you look for handouts. And the handout I'm talking about is called partial fraction. Partial fraction decomposition. Okay, find that handout. It's gonna look like this one. It's several pages, but the first page is the steps and then the rest is examples. Start with a proper rational expression. What do we mean by proper rational expression? Meaning the degree of the numerator less than the degree of the denominator. If you look at the denominator, this is x times x squared minus 1, it's x cubed minus x. So the degree of the numerator has to be less than the degree of the denominator. If it's equal or greater, then you gotta do long division first. If not, do long division first. Again, the degree of the numerator has to be strictly less than the degree of the denominator. The numerator has a degree less than the degree of the denominator. Then you want to factor the bottom into either linear factors or reducible quadratic factors. Reducible quadratic, like you could end up with x squared plus 1. This is a quadratic, but you cannot factor it anymore. Write out a partial fraction for each factor and every exponent of each. Meaning if you have in the original one like 2 over x minus 1 squared times x plus 1, you write 2 over x minus 1, a over x minus 1, b over x minus 1 squared. You write 1, so you write the exponent is 2, you're going to write 2 of them, one linear and the other is quadratic, and then b over x plus 1. When you have a quadratic factor, you need to include this partial. So if you have a quadratic at the bottom, then you put linear on top. If you have linear on the bottom, you put a constant on top. Is that the degree of the numerator is always 1 less than the degree of the denominator. Then you multiply by the original fraction to clear out all the parentheses, all the denominators. You solve for the coefficients, the a's, the b's, and c, and then you substitute zeros for the bottom. We can do it a different way, making a system of linear equations and solve. Well, I'll explain that. First examples, we go over that, but these are the steps. Okay. Now, so let's go. So we're gonna go backward. How do we go back in this one that we did? This is one of the 4 cases that we're gonna go over. So case 1. is when you have distinct linear factors in the denominator. How do we break it down if we have distinct linear factors in the denominator? So decompose, example 1, decompose into partial fractions. Eight x over 2 divided by x squared minus 1. So the first step is to factor the bottom. The bottom is going to be x plus 1, x minus 1. Write out a partial fraction for each factor. So each factor, x plus 1 is a factor, x minus 1. Since we have a linear factor at the bottom, so we're going to put a constant on top. So we put an a and a b, any constants. And then multiply the whole equation by the bottom of the original fraction. So x plus 1, x minus 1 is we're going to times by. So we're going to times by x plus 1, x minus 1 to clear out all the fractions. So that's going to give me 8x plus 2 equals a times x minus 1 plus b times x plus 1. So now we want to, this is an equal equation, so we want to make the x terms equal the x terms and the constant equal the constant. So to do so, we want to distribute ax minus a plus bx plus b. So let's write this side like that side. So we're gonna put these two together, factor out x, will be a plus b, and then minus a plus b. So this is your x term has to equal the x term. So 8x has to equal a plus b, or a plus b equals 8, and the 2 has to equal the constant, negative a plus b equals 2. Solve by elimination. B plus b is 2b equals 10. B is 5. And we go back and plug it in one of these to get a. A plus 5 equals 8. A is 3, and the expression 8x plus 2 over x squared minus 1 is 3 over x plus 1 plus 5 over x minus 1. So this is one case where the denominator has distinct factors. The second case, case 2, where the denominator has repeated linear factors. So how do we decompose into partial fractions? For x squared minus 1 over x plus 1 squared. So you can see the bottom has x plus 1 squared, which is repeating. So remember what it said here. First, we want to factor the bottom. It's already factored. Write out a partial fraction for each factor and every exponent of each factor. So if x is a factor, we write a over x. It's linear, so we put a constant. X plus 1 is a factor, again it's linear, we put a constant. X plus 1 squared is a factor, it's linear. The only time it's quadratic at the bottom one, it cannot be factored. So this is factored, so it's linear, and it's c over x plus 1 squared. And then we multiply by the LCD, which is the original fraction, x plus 1 squared, x plus 1 squared, x plus 1 square, x plus 1 square. So that's gonna cancel all the denominator. We get 4x squared minus 1. The x cancels, a, and then x plus squared is x squared plus 2x plus 1. We FOIL it. This one of these cancel one of those, so bx times x plus 1 is we're going to be distributed, and then x plus 1 squared cancels out cx. So we want to equal both sides. Distribute ax squared plus 2ax plus a plus bx squared plus bx plus cx. So we have ax squared plus bx squared, which is a plus bx squared. We have 2ax plus bx plus cx. We factor out the x, we get 2a plus b plus c. And then there's only one constant a. This has 4x squared, it has no x, so we put a 0, and then minus 1, because these two sides have to equal. So the 4 has to equal a plus b. The 0 has to equal 2a plus b plus c. And the a has to equal negative 1. So we already have a, then b is going to be 5. Right? 4 plus 1. We have a, we have b, and then we can find c from there. 2 times negative 1 plus 5 plus c 0. That's negative 2 plus 5 is 3. So c is negative 3. And now we gotta write out the problem. So 4x squared minus 1 over x plus 1 squared. It's a, which is negative 1 over x plus b, which is 5 over x plus 1 plus c, which is negative 3 over x plus 1 squared. And that's how this fraction can be broken down. The third case, when we have a distinct linear and quadratic factors in the denominator. Distinct linear and quadratic factors in the denominator. If you have something like this, 3x squared minus 7x minus 2 over x squared plus 1. So you can see in this case x is linear, x squared plus 1 is quadratic, it's prime, you cannot factor it, so you're stuck with that. So for each factor at the bottom, we're going to have a fraction. For x, we put a constant. For x squared plus 1, we're going to put linear. Remember that handout? So for quadratic, with linear, ax plus c or ax plus b or bx plus c, it doesn't matter. So we already have an a, so we're going to do bx plus c. And now we times everything by the original denominator, which is x squared plus 1. x plus 1, x squared plus 1, get rid of all these fractions. So this is going to be 3x squared minus 7x minus 2, ax squared plus a, and then plus bx squared plus cx, distributing the x. So 3x squared minus 7x minus 2 equals a plus b, factor out the x squared, and then cx plus a. So a plus b is going to equal 3. Negative 7 is going to equal c. So c is negative 7. And then a equals negative 2. So we go here, negative 2 plus b equals 3, b is 5. And let's write out the answer, 3x squared minus 7x minus 2 over x squared plus 1 is negative 2 over x plus b x plus c over x squared plus 1. The last case is when you have repeated prime quadratic factors in the denominator. Case 4, repeated quadratic prime factors in the denominator. Example 4, so how do we decompose x cubed minus x squared plus 2x over x squared plus 1 squared. So you know we have a quadratic and it's repeating twice. For every one we put a fraction, x squared plus 1, x squared plus 1 squared. Since the prime factor is quadratic, so we're going to use linear on top, ax plus b, and then cx plus d. And then we're going to times by the original denominator, x squared plus 1 squared, x squared plus 1 squared, x squared plus 1 squared. So that's going to take care of all this. And then we have x cubed minus x squared plus 2x. X squared plus 1 was 1, so we have a plus b. We're going to FOIL it in the next step, x squared plus 1. And this would be cx plus d. So let's FOIL. So it would be ax cubed plus bx squared plus ax plus b. And then bring this guy down, cx plus d. Let's group them together, the x cubed together, the x squared together, the x together, a plus cx, and then b plus. And then they should equal what's on the left side. There is no constant, so the constant is 0. So 1 is a, negative 1 is b. We already have 2 out of 4. And then 2 is a plus c is 2, a is 1, so c is 1, and then 0 is b plus d, 0 is negative 1 d, so d is 1. So let's write out the fraction, x cubed minus x squared plus 2x over x squared plus 1 squared equals ax, so 1x plus b over x squared plus 1 plus cx 1x plus d over x squared plus 1 squared. Amazing, huh? Okay, finally, remember what it says here? Start with the proper rational expression, if not do long division. So if the degree of the numerator equal or greater than the degree of the denominator, we do long division first. Here's an example. 2x cubed plus 6x squared plus 5 minus 7 over x squared plus 2x plus 1. You can see the degree here is 3, the degree there is 2, so we're going to do long division. 5x minus 7 over x squared plus 2x plus 1. So 2x cubed over x squared is 2x, so it would be 2x times x squared is 2x cubed, 2x times 2x is 4x squared, it's times 1, 2x, switch the signs, minus, 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 so that's 2x squared plus 3x minus 7, 2x squared divided by x squared is 2, so 2 times x squared, 2 times 2x, and 2 times 2, again switch the signs. So negative x minus 9, so it's plus negative x minus 9 over x squared plus 2x plus 1. So now this is what we're going to work on. Okay, so how do we decompose negative x minus 9 over x squared plus 2x plus 1, which is x plus 1 squared? You should be able to do that. I'll give you the answer. It's going to be negative 1 over x plus 1 plus negative 8 over x plus 1 squared. Okay, and that's it for 10.7 until 10.8. Have a good day.